With what name you have logged in, sir, so that I can search you?
Srinivas Nayak. Dr. N. Srinivas.
1 minute, sir. 1 minute. Yes. Yes, Manasa madam, you can start. Hello, Manasa madam. Yes, madam, you can start.
Okay, sir. Distinguished guests, respected principal, head of the department, esteemed faculty members, and dear participants, a very good morning. I am Manasa, working as an assistant professor in the Department of ECS. On behalf of the organizing committee, welcome you all to this 5-day FDP on the future of computing, emerging technologies and trends. I deem it an honor to introduce the resource person for today's session. Dr. N. Srinivas Nayak is a distinguished academic professional with a computer science and engineering background. Holding the position of Assistant Professor Grade 1 at IIIT DM Kurnool, he has made significant contributions to research and teaching. His educational journey includes completing MTech and PhD in computer science from the University of Hyderabad, where his doctoral research focused on scheduling approaches to enhance map-reduce performance in heterogeneous environments. This showcases his expertise in cutting-edge technologies, particularly in the field of big data computing. Dr. Naik's research achievements are noteworthy with the successful execution of multiple funded projects where he served as the principal investigator. These projects, supported by government funding agencies like MEITY, SERB, and TIH-IIT Bhilai, have collectively received substantial budgets totaling 1.6 crores. His research projects, such as smart agriculture for tribes using artificial intelligence and big data, and identification of diseases in millet crop using deep learning, demonstrate his commitment to addressing real world challenges through innovative solutions. Furthermore, Dr. Nayak holds an Indian patent for his work titled Smart Electricity Metering System and Method thereof, highlighting his contributions to technical advancements. He has also made significant contributions to peer reviewed international journals and conferences, further establishing his presence in the academic research community. Beyond academia, Dr. Nayak has been pivotal in organizing and coordinating various workshops, promoting collaboration and knowledge exchange. Notable among these are the national level workshops on blockchain technology and sensory networks, Internet of Things, and the Internet of Everything funded by DST. Dr. Noak's commitment to academic excellence extends to his active participation in outreach activities. As an IEEE senior member, he holds key positions as the secretary and treasurer for the IEEE Hyderabad CIS/GRSS joint chapter, emphasizing his dedication to community engagement and the professional development of his peers.
Thank you, ma'am. Shall I share the screen?
Yeah, thanks, Madam, for introducing the Srinivas Nayak, sir. A warm welcome to all of you, sir. Dr. Srinivas Nayak, sir, you can take over the session?
Yes. Can you see the screen?
Yes, sir.
Yeah. So today in today's session we will discuss about the big data. So what kinds of
Sir, can you please check the voice is not audible, sir?
Sir, now it is okay, sir.
Now it's okay.
Now it is okay.
Yes, sir.
పుచ్చిపోయింది.
Sir, can you please check, sir? It's not audible, sir. Your
Audible,
voice.
sir. సార్ మళ్ళీ పోయింది.
Is it okay now? I'm audible. Hello.
Yes, sir. Yes, sir. Now it is audible, sir.
So is it okay for everyone?
Yeah. Please respond with a message, please. Is it okay for all?
Yeah,
Good.
it's okay, sir, now.
Yes.
Yeah, good, sir.
So I'm sharing the screen again.
Okay, sir.
So can you see the screen?
Yeah, very much. Your presentation is visible, sir.
Sir, like if any disconnection in between, please call me, sir, so that
Sure,
I
sir.
can
Sure, sir. Sure, sir. Sure, sir.
because today there are some interruptions might be there at our institute.
Sure, sir. Sure, sir.
Yeah. So we'll start with the basics. So we will make this session as more interactive. So I don't want to make this session as boring. So that's why I have kept most of the slides, like we are having the images, some animations like that. So we will make this session as interactive. Like it should not be one way because you are not listening to any YouTube lectures, right? So here we are having the live session. In the live session, it is better to have the interactive sessions. Otherwise, it may not look good. Means it will be more productive if we have the interactive session. Can you tell me what is big data? So what do you know about big data? Yeah, whatever you know, you just you can tell me what is big data.
Basically, the size of the data which goes beyond the normal sizes. There is no specific limit. Like normally we used to work with earlier, like years back, we used to work with the MBs of data. Then we went on to GBs, then petabytes. If something goes beyond our normal capacity of PCs, that can be termed as big data.
Yes, somewhat it is true, right? So basically, the big data is not only about the size. So there are some V's are there that they have defined, like volume, velocity, variety, veracity, and value. Those will come under the big data. If all these five satisfies, then only we call that it as a big data, right? So and what is the there is no proper definitions for the big data. So everyone is defining based on their own capacity. So, but in general, the big data is, suppose if you are having the data that we cannot store the data in a normal traditional systems, right? And such kind of data, as well as if you cannot process such kind of data, right, using the normal traditional systems, means what we are doing in a single system, right? So we are not working on a distributed environment, and we are not working on a parallel processing. So whenever we are having big data, so we cannot approach the traditional approach. So we have to go to the non-traditional approach. What is the non-traditional approach? The non-traditional approach is we have to divide the data into set of blocks, and we have to distribute the data across the nodes in the cluster. Then we have to do the parallel processing so that the data will, so we will get the results immediately. Means we can work on the batch processing as well as the interactive processing in this case. So mainly the big data is used to, the major purpose of this big data is used to how you are going to store the data and how you are going to process the data which has been stored in the cluster. And suppose for the process, so we can do some analysis, right? What kind of analysis that we can perform on the big data? So here we can discuss about the big data analytics. So we can perform, because if you see some of the companies are having huge volumes of data, right? And they are having their own big data clusters. So during their processing, what actually they want to do, they want to analyze. Suppose if you see some of the e-commerce websites are there. So what they will analyze, which customers, they will categorize the customers, and they will see which of the customers are preferring what kind of products during which day, something like that, right? So there is some analysis on the data that which they are having. Understood? So big data is mainly used for analyzing the data. So as we said, so big data we are having the 5 E's. So basically we should understand if it satisfies all the 5 E's, then only we can say that the data is big. If it is the data is in huge volume, you cannot say that the data is big data, right? Based on only volume, you cannot say, but it should have the variety, it should have the velocity, it should have the veracity, it should have the value. So we'll discuss each one of them. So what do you mean by volume here? What is the meaning of volume? If you see here in this slide, so what do you mean by volume here?
The size of the data.
Yes, the amount of data that is being generated, right? So how much amount that is being generated? If you see the data, like like if you see 48 times the data has been increased from 2009 to 2024. It means 8 zettabytes to 44 zettabytes. So what we will get from this one? So the data is increasing exponentially, right? So whenever the data is increasing exponentially, so the major concern is how we are going to store the data, right? So that we will see. And who is generating the data? Someone should generate, right? So if you see cyber networks are generating the data, and if you see in each mobile phone or everywhere we are having the tracking, right? And the social networking, and from the e-commerce websites and from financial services, from the real-time search. So all these companies or organizations or individuals, everyone is generating the data, right? So earlier, what is the concept of earlier? In the earlier case, only some of them are generating the data. We are using the data. Means organizations are generating the data. We are using the data. But if you see nowadays scenario, we individuals are also generating a lot of data, right? So what are the major sources? Like as we said, the social media networks are the major source of the data. And so data for scientific calculations, they are getting the data from scientific instruments from various from space and from other resources, right? So here the data is the data set size is very large, right? One file size might be in GBs, right? So how they are going, how they are collecting the data, and the from the mobile devices, right? From the mobile, if you see the tracking is there in each and every mobile phone. So for that, and many of the applications are having the tracking, right? So each one of the applications are also generating the data, and as an individual, we are also generating the data. And if you see most of the nowadays, if you see in the cars that we will use, and at the home, the ACs, wherever you like, wherever we see the daily usage, so we are having the sensors everywhere. We are having the sensors. So each sensor is generating the data. So these sensors are, if they are connected in the internet, right? If they are not connected, then it's okay. But if you see you in your car, right? So your car is tracking by someone else, right? Right? So that car is generating the data, right? So here, because that they are having the sensor there. Wait for a second. Meeting match. So here we all are generating the data. So what is variety? Till now we have discussed about the volume, right? The volume is the how much data that is being generated. So what is variety here? So we are not generating only one type of data, right? So here we are generating different types of data. Understood? So they have categorized these types of data into three. One is structured data, semi-structured data, and unstructured data. What is structured data? Which follows a schema, right? So like RDBMS. So means what? So here we will define the schema, and then we will after defining the schema, we will insert the data and we will perform some operations on top of it, right? That is the structured data. What is unstructured data? So here we will not define any schema for that. Just we will load the data and we will process the data. Similarly, we are having semi-structured data. Semi-structured data means what? So here we are having the XML files, CSV file, JSON file. So it follows both structured and semi-structured type of data. So in the earlier case, most of the data is structured data. 80% of the data was structured data in the earlier days, and the unstructured and semi-structured data is very less. So mostly we were going towards the RDBMS, right? But nowadays, if you see, 80% of the data is structured, unstructured and semi-structured data. So to handle such kind of data, so we will not move to the traditional approach, right? So we'll see why we are not moving to the traditional approach. What are the limitations there? So either it is structured data or semi-structured data or unstructured data. So what is your major concern? So you have to store this data, right? So where you are going to store the data? So you cannot store this data in a single system, right? Because the space is not available in a single system. If the space is available also, to process that such amount of data, it takes a lot of time. Instead of that one, what we can do, we can divide the data into set of blocks and we will distribute that set of blocks across the various nodes in the cluster. That is called distributed storage. Now we have stored the data in a distributed manner, right? Once you have stored the data in a distributed manner, then we perform the task. Means you have to process the data, right? How we are going to process the data? We have to process the data parallelly, right? Whatever the data block that we have divided, so on each data block we have to run some task. So here we have to run the task parallelly, right? Then only it will give the results quickly. And if you see here, as we discussed, we are having various types of data, right? So all these types of data are required. Yes, right. So sometimes, some of the projects will come where you need to work on all these three types of data, right? So why they need to work on all these three types of data? To extract some useful information, right? To extract something meaningful from that one, because we need to perform some analytics on top of it, right? So as I said, so if you see here in this slide, as a single user, right? As a single user or customer, if you see how many accounts I'm having the social media accounts, I'm having the gaming accounts, I might be having entertainment accounts, e-commerce accounts, and banking finance accounts. As a single customer or user, I'm having these many accounts. Means how much data that I'm being generated, right? So I'm generating how much data? So I'm as a single user, I'm generating lots of data, right? And if you see like that, we are having millions and trillions of users. So if you consider all these, so how much data that is being generated? So the data that is being generated, and I'm not generating only one type of data, right? So here the various different types of data that we have discussed, structured, semi-structured, unstructured, all these types of data that is being generated by the single user. And if you combine all these things, so you can imagine how much data that is being generated every day. Next, velocity, right? What is velocity? The speed at which the data is being generated. So till now we have discussed volume, the amount of data, and we have discussed variety, different types of data. Now we are discussing velocity. Means how like what is the speed or frequency at which the data is being generated. Understood? So where it is useful, it is mainly useful for taking a decision in online, right? In real time. So means what, if you see some data streaming is happening, right? Some data streaming is happening, and I have to make a decision on that at that point of time. So online, some data analytics we can perform on the go, and we can make a decision. For that, this kind of thing is means I mean to say that the big data is used in this way also. Means we are having different types of data. So here you see how much data that is being generated. So you see Google, how much data that is, because it is old data. So you see how much data that is being generated by Google, Yahoo, eBay, Amazon Web Services, Facebook. So here I mean to say that there is a lot of data, and that data is generated in a the time frame. We are discussing about the time frame, how much data that is being generated in a time frame, right? So if you see in this slide, so for every minute, how much data that is being generated through social media or the internet or the various platforms, you see how much data that is being generated in a minute. So assume that how much data that is being generated every day. So according to IBM, so what they said is 90% of the information will be double. It will double in 2 years. Understood? So like means what, the data is like the speed at which the data is being generated. That's what they are speaking about, right? So till now we have discussed about the volume, and we have discussed about the variety, and this we have discussed about the speed, right? Now we are having, assume that we are having lot of information, lot of data that we are having, right? So what you are going to do that with the data? And because when you are having lot of information, right, lot of information, lot of data, assume that suppose your in your laptop or in your system, you might be having some n number of images that you might have captured long back, right? So you might be having some thousands or lakhs of images in your system, right? But those images might not be useful, right? I mean to say that only some of them might be useful. Most of them might be having the noise, I mean to say that they might be having the duplicate copy of the data. Some data is not accurately captured, something like that. Okay? So here I mean to say that here we are having lots of information, and that all the information may not be useful, right? So here we will not only speak about the quantity. So here volume means quantity, right? So we will not only speak about the quantity, but we should make sure that the quality should be there, right? Whatever the data that we will collect, so we are not only focused on the volume, right? We should focus on the quality also. Understood? So if you see here, that is called veracity. Okay, veracity means like how much quality of data that you are having. So if you see, as per the data, 98,000 deaths are happening each year caused by the errors in the medical data. Understood? And 81 million national insurance numbers are there, but only 60 million eligible citizens are there in the Europe. Okay, 5 lakh dead people retain their active Medicare cards, right? So data error in the industry is around 30%. So what exactly that we are saying here? So we are not having the correct data. Okay, we are not having the correct data. We are not having the complete data. We are having the inconsistent data. So here, that's why we should focus not only on the quantity, and we should also focus towards the quality. Here veracity mainly discuss about the quality of the data. Understood? So what will happen, suppose you are not having the quality data? What will happen? So you are having huge volumes of data, you are having the quantity, but you don't have the quality of the data. You are not able to extract the quality of the data. Then what exactly you need to do? You need to spend a lot of money towards it, and you need to spend a lot of manpower to extract some useful information out of it. So because of that, you may lose the revenue, you may lose the credibility with your clients and the customers. Okay, so there are a lot of financial uh, like mistakes may happen, right? So so that's why whenever we are having the data, we should make sure that the data should have the quality data also. Okay. And if you see, suppose assume that I am having the quality data, right? So I am having the volume of the data, we are having the variety of data, I am having the velocity of the data, I am having the veracity of the data, right? So but some of the organizations, they don't know why they have collected the data. Assume that they have not done the proper study, or then what is the use? If you have collected the proper data, and if the data is not useful to you, then there is no use of collecting it, right? Understood? So here we are speaking about the value, right? Here we are not only speaking about the volume, velocity, variety, veracity. It should also add a value to the customer, or it should also add a value to the end user, or it should also add a value to the company, right? Understood. So whenever I am collecting some data, suppose I have collected the quality data, right? I have collected the quality data, and if the quality data is not useful for me, right? If the data is not generating any revenue for me, or it is not generating, or it is not giving any useful information to my company or the clients, then there is no use, right? So you should have the value also. Understood. So whenever we are going for the big data, you should make sure that all these 5 V's should be satisfied. Understood. The one is volume. The volume is the amount of data that is being generated by various organizations as well as the individuals, and the velocity, the speed at which the data is being generated, right? And the variety, we are having different types of data, and veracity. Understood. Veracity means what? Quality of the data. Wait first. Right. So here, quality of the data, and you should get some value out of it. Suppose if you take an example of an hospital, right? Assume that you have taken the patient records. Okay, you have taken the some huge volumes of the patient records data, right? And also the test results data, and you have taken those data on time. Understood. So you are taking the data on time, and in that data, so you might be having different types of data, right? One is you might be having some scanning reports, and you might be having some descriptions. You might be having some text data. You might be having image data. You might be having some video data, right? So you might be having some different types of data, right? Like that, right? And what is the veracity here? What is the quality here? How much accurately you are identifying the particular disease, right? And that will build the trustworthiness among the patients, right? So what value you will get? What is the value that you will get? You will get the money, right? And you will get the the trust that you will get among the customers, right? And you will accurately identify the disease, and if you accurately identify the disease, then you will go for the better treatment, and it will reduce the cost for the end user also, right? So this is a just use case scenario why we are going for the 5 weeks. So let us see why this big data is not possible earlier, why it is only possible now. So what is the earlier case, and what are the traditional approach that we are having, and what is the big data approach that we are having now, right? So can you tell me what is the traditional approach? So in the earlier days, we didn't have the big data, right? Understood. So mostly the most of the data we might be having, but that structured data is more, right? So for that, what we are having? So we were having the application server, we are having the database server, we are having the data, right? So here, can you tell me what is the issue with this kind of traditional approach? What is the issue in this traditional approach? So is there any issue here? Is there any do you find any limitation in the traditional approach? Because there are some issues in the existing approach, then only we move towards the advanced approaches, right? So what is the limitation here? It is already written here. So can you tell me what is the limitation that the traditional approach is having? Am I audible?
Yes, sir. Yes, sir. Very much audible, sir.
Yeah. So in this traditional approach, what is the major concern is, so where actually our data is there? The data is there in the database server, right? And what is the application server is having? The whatever the log that you will write, right? Whatever the query that you will write, that will be processed at the application server. Understood? So here, in order to process the data in the application server, it has to get the data from the database server to the application server, right? Here it will be processed. Again, the results will be given to the end user, and the remaining thing will be updated in the database server. So what is the major problem that we are getting here is the network bandwidth, right? So we are having the less network bandwidth. If the data is in, yeah, it is in KBs or it is in MBs, it's okay. But if your data is in GBs, then you think about it, how much time it will take to get the data from the database server to the application server, and again from application server to the database server. It takes lots of time, right? So the processing is different case, right? So the data transfer itself, it is taking a lot of time, right? So then what is the big data approach that we are having? So what is the solution for this one? So instead of having the servers, what exactly we were having is commodity nodes, right? So in the commodity nodes, what exactly they are doing? So the first thing is they are dividing the data, as we discussed earlier. They are dividing the data, and the data has been distributed across the data nodes, right? And once the data is there, right? So you will write some logic, right? You have to process the data, right? So simply storing the data may not be useful, right? So you have to process the data. In order to process the data, you have to write some logic, right? So based on your requirement, you will write the logic. So whatever the logic, suppose if you assume that you are writing a Hadoop job, right? So in the Hadoop job, you have to run the mapper function and the reducer function. And this mapper function, reducer function is the logic, right? So where this logic will run here? So this logic or the function, it will go to the data where the data is residing, right? It will go to the data node where exactly the data is there. So at that particular point of time, the data means what in that particular data node, the data will be processed. Understood? So here we are saving a lot of time, right? We'll discuss these things in detail. So here I mean to say that in the traditional approach, we are moving the data towards the logic. In the big data approach, we are not moving the data, right? Because the data is huge, right? So we are moving the logic. The logic will not go beyond MBs, right? Mostly it will be in KBs, but it will not go beyond MBs, whatever the logic that you will write. So because it will be easy, right? So we are moving the logic towards wherever the data is there. So here also there are many constraints are there, but this is the basic funda. So then why we are going towards the big data? Because if you see, as we discussed, many of the companies or organizations are generating lots of data, right? And they are collecting the data, and they have to analyze the data. Based on that one, they would like to improvise their customer satisfaction or some other thing, right? So there are many applications of big data. That's why they are like these companies are going for that one, right? So if you see the applications like in healthcare, transportation, telecommunication, financial services, the IT, the retail industry. So if you see everywhere they are using the big data. I mean to say that the approach might be different, but everyone is using the big data to analyze their value inside it. So what are the challenges here? So we know that we are having the big data, but there are a lot of challenges out there, right? So suppose assume that you are based on the volumes of data that you are having. So how you are going to store the data, right? Suppose it is if you consider the velocity, right? Then you need to have the real time processing, right? Like Apache Spark, right? And how you are going to load such kind of data, and right, and suppose once you have having the data in the cluster, right? So how you are going to process the data, right? Understand? Then how you are going to maintain the scalability and data quality, right? Scalability means what? So at this point of time, the data that you are having might be 30 GB, but in future the data size may increase, right? So accordingly, you need to increase the data nodes also, right? How scalable you are, and you need to make sure that your data is secure. So these are the various challenges. So we try to address some of the challenges, right? So if you see here, so in 2000, what the Google has done is, so there are n number of internet users are there. Means they are growing, right? They are growing exponentially in the year 2000, like that, right? So they have faced a problem like storing the data. Right? So earlier they used to store the data in the traditional data servers, but when the data is huge, storing as well as the processing, it will take a lot of time, right? As we discussed, understood. And what are the other major issues is that is one is storing purpose, and other is they are having many means they are having many search queries, right? So how you are going to process those search queries, okay? And these query may require hundreds or 100 MBs of data, right? Understood. And it will take a lot of CPU cycles also. So for that, what from the Google, what they have, like there are some authors, there are some scientists like Sanjay Gemawat and Jeffrey Dean. These are the scientists who came up with some solution called Google File System. Understood. So in the Google File System, they have just divided the data into chunks and then process the data. So we are having many big data open source tools. So these are the various open source tools that we are having. So if we consider the framework, any query you are having, Can you switch off your mic? Speaking. So, please, organizers can switch off your mic.
Sir, it seems somebody is. We'll mute everyone.
Yes, please mute. So here we are having the framework, right? So what is the framework here? The platform, right? The platform on top of.
Sir, you please unmute, sir.
Am I audible now?
Yeah. Now it's good, sir.
Yes, screen
Sir,
is
from
also
your
visible.
side, if you get any disturbance from other people, you can just unmute all, sir.
Okay.
Mute and
Can you see the screen?
yeah, it's visible, sir.
Yes. So as I'm saying is we are having various frameworks for different purposes, right? One is for storing the data. We are having the Hadoop distributed file system, and for processing the data, we are having the MapReduce engine. It is mainly used for the batch processing. And suppose if you want to do the real-time processing, then you can go for the Apache Spark, right? And on top of it, you can have some machine learning libraries like MLlib, Mahot. There are many other libraries out there. So these are the various open source tools. If you are going for the search, Elasticsearch is there, and for the visualization purpose, you can use the Zeppelin, and for the data access, you can have the Cassandra, Apache HBase, MongoDB, right? So if you want to have the coordination among all the, suppose if you are having various platforms in the cluster, right? So if you want to have the proper coordination, then you can go for the Apache Zookeeper or Apache Ambari. And if you want to use some statistical tools on top of it, right? You can go for the R, Scala, NumPy, so SciPy. So everything is available here, right? So if you want to run some queries, right? You can go for the Apache Hive. So I mean to say that these are the various big data open source tools which are available. You can explore based on your requirement. You can explore all these tools. So as we discussed, what are the challenge? So the major challenge is storing the data in a single server. It is a challenge, and what is the solution? We are going for the distributed storage and processing also. If you want to, whenever you are having the like large data, then processing the data in a single system will take a lot of time, because the you might be having the processors, very limited processors there, right? So instead of that one, we are going for the parallel processing. If each node is having dual core also, if you are having 100 nodes, then you are having 200 cores you will be having, right? So the parallel processing will be improved. So the solution is we are focusing the solution towards the Hadoop. So this is the real time Hadoop cluster that is there in the Yahoo, right? So this is the rack. In each rack they might be having around 200 to 300 nodes, and like that they might be having around 200 to 300 racks. Approximately they might be having around 3,000 to 4,000 nodes. Excuse me. So why we are moving towards the Hadoop? So you are the user, right? So you are the user. So you don't need to worry about what are the things that you don't need to worry about. So you are storing the data, right? In the earlier distributed storage systems, in the earlier distributed systems, you need to track about where your files have been located in the distributed system. Earlier it was there, right? But in the Hadoop, you don't need to worry about where actually your file is located. Suppose you are having some errors, or you are having some failures at node level or data level or at the cluster level. So you don't need to worry about whether your data is, you might be losing the data or like that, right? So everything will be handled by the framework or the cluster, okay? And you don't need to worry about how you are going to divide your logic, right? So how you are going to process that one, right? Understood. And you also no need to worry about in the earlier days, if you want to write a program for like whatever the program that you will write, it might be working on some suppose 10 systems. Suppose you have increased the scale, right? Increase the number of systems, right? Then again you rewrite. You need to rewrite the program such a way that it can work on the another 10 systems. Okay? But here you don't need to worry about the scaling also, right? So mainly the Hadoop offers the redundant, fault-tolerant data storage that we will discuss, and it will allow the parallel computation framework that also we'll discuss, and it will allow the job coordination. So how the jobs will be coordinated. So we'll discuss each and every aspect in detail. So to get some motivation, so why we need to study about Hadoop or any other framework, the big data framework. Not only Hadoop, you can go for any other framework, but Hadoop is the basis, right? So why these many companies are using the Hadoop, right? So because it is having the reliable data storage as well as the it will process the data quickly, right? So if you want to set up the Hadoop cluster, if you want to set up the Hadoop cluster, so what we will teach in our class is we will not go for any commercial Hadoop versions, right? Because they may not learn anything, right? So in the commercial Hadoop cluster, what will happen is everything will be hidden, right? So only you will get the front end, right? So where you can just submit the data, but you don't know what exactly happening at the back end. So if you take any of the commercial versions, right, distributions. Whereas when it comes to the open source Apache Hadoop, so here we will do everything from the scratch, right? So because Apache cores are available, whenever the Apache core is available, so you can, so we need to follow some set of instructions which are already predefined. Some errors might be there, so that can be rectified. So, but we will prefer in future if you want to set up the cluster in your institute, we will prefer you go for the open source Apache Hadoop framework. So what are the main characteristics of the Hadoop, right? What is the major characteristics? One is scalable, right? So what is the meaning of scalable here? Suppose in our there are two types of scalables, right? One is horizontal scaling, one is vertical scaling. What is horizontal scaling? Horizontal scaling is in your institute. Suppose you have set up the Hadoop cluster of 10 nodes, right? So in future you may need to add another one or two or five or another 10. You can do like you can add any number of number of nodes, right? That is called horizontal scaling. And what is vertical scaling here? Suppose in your nodes, whatever the node that you are having in your cluster, in that particular single node, the whatever the RAM or the number of cores or the processor that you want to upgrade, right? So you want to increase the memory size or you want to increase the number of cores, that can be done within the node, right? Within the single node. That is called vertical scaling, right? What is flexible here? So flexible is based on, suppose you are having based on your number of nodes, you can store, because there is a limit in the storage of the data and also processing of the data. But limit is depending on the number of nodes, right? And number of nodes and node capacity also. Node capacity to store and node capacity to process the data. But assume that you are having the enough number of nodes to store and process the data, then there is no limit. You can store as much as data you can based on your node capacity, right? And economical. What is the meaning of economical here? So, like earlier, we used to have the servers, right? In servers, we are having the servers are very costly, right? So, but in our cluster, whenever you are forming the Hadoop cluster, right? Here you will not use any servers, right? You will not use any workstations also. You will use the normal traditional systems, right? So, like we can say the commodity hardware. You will use the commodity hardware because that will cost you less, right? Understood. Because if that node is failed, also it's okay. That we will see if the node failure happened, then what is the case, right? Another one is the reliability. What is the reliable here? Because we are having the commodity hardware, we should make sure that anytime the node may fail right? So if the particular node is failing, right, then whatever the data is there in that particular node, that should be replicated. Otherwise, you may lose the data, right? So in this big data, the data is very important, right? If you lose the data, then there is no essence of doing all those things. So how we are making the data reliable is we will see in the coming slides. So if you see, this is the broader Hadoop ecosystem that we are having. If you see, for storing the data, we will go for the Hadoop distributed file system. And if you want to manage the resources efficiently, we are going for the YAR. And if you want to go for the batch processing, then we go for the MapReduce. And if you want to go for the real-time processing, we can go for the Apache Spark, because here everything will be processed in memory. And suppose if you want to go for the any analytical or SQL on top of Hadoop, then you can go for the Hive. And if you are going for the streaming data, right, if you are having the streaming data, then you can go for the Apache Kafka or Apache Storm. And suppose you in your problem statement, you may need to work on some of the machine learning libraries, right? So these libraries are also available. Suppose if you are going for the MapReduce, then you can work out on the Mahout. Some of the existing machine learning libraries are already available. And if you are working on the Apache Spark, our real-time processing, then you can go for the Spark MLlib. The machine learning libraries are available. If you are going for the scripting languages, then Pig is available. And as I said, for searching and indexing, the Solar and Lucene is available. And for NoSQL database, right? So if you want to work on the NoSQL database, HBase is available. And for scheduling, Uzi is available. And for management, as I said, Apache Ambari is available, right? And if you want to feed the data, right, if you want to feed the data from some other source, right, then the scoop is available. If you want to feed the structured data into the cluster, or if you want to feed the unstructured data or semi-structured data into the cluster, then the Flume is available. So I mean to say that this is the complete ecosystem. This is the complete ecosystem where you can work upon, right? So because it all depends on your requirement, right? It all depends on the problem statement that you have chosen, or the requirement from the client, or so it all depends on the what kind of problem that you are addressing. Based on that one, we can work on this one. So in this session, we will discuss about the HDFS, we'll discuss about the MapReduce, we'll discuss about the YAR. If time permits, we'll discuss about the Spark also. As we know, we are having big data for storing and processing and analyzing the data. That already you know about it, right? So for storing, how we are going to store the data? So you need some framework, right? So Hadoop provides Hadoop distributed file system, right? Hadoop distributed file system is used to store the data, right? So then you need some other engine, right? Some other engine to process the data. So here you are having the Hadoop MapReduce. So here Hadoop MapReduce will process the data, right? Hadoop MapReduce will parallelly process the data in the cluster, right? And if you want to suppose you are at our institutes, we can go for MapReduce. But if you see the companies, because the companies might be having the 1,000 node cluster or 2,000 node cluster, right? In that big clusters, it will be very difficult to run only MapReduce, right? Because the companies might be requiring, as we said here, this complete ecosystem. The company might be requiring this complete ecosystem, right? If you want to have the complete ecosystem, then you need to have the Apache YARN, right? So what the yarn will do? So it will efficiently manage. It will efficiently manage all the resources whichever there on top of it, right? You can run the MapReduce job. You can run the Spark job. You can run any other job, right? Whatever is available, you can run all these jobs. So the yarn will provide the basically it will provide the management of the resources to different tools or frameworks which are available on top of it. Understood? So what exactly the cluster will look like, right? So the cluster will have the racks, okay? The cluster will have racks, okay? What this rack will contain? The rack will contains the nodes, right? So what are the nodes that we are having? We are having either master node or the slave node, right? We will be having master node or slave node, because in a distributed systems, we will be following majorly in this cluster. We will be following majorly master slave architecture. In the master slave architecture, we are having the master node as well as slave nodes, right? So I will discuss about the name node and job tracker later. So assume that name node is the master node for the Hadoop distributed file system, and job tracker is the master node for the MapReduce engine. Understood? And this data node and task tracker. Data node is the slave node for the Hadoop distributed file system, and task tracker is the slave node for the job tracker. So the data node and task tracker need not to be in the, it must be in the same node, right? Why? Because the data node contains the data, right? And what task tracker contains? The task tracker contains the task. We will divide the job into set of tasks, right? That task needs to be there in the data node because the data block is present in the data node, right? Data node, right? So these two should be in the same node, slave node, right? Understood? So here we are having the name node as the master node and other nodes are the slave nodes. Here in the rack 2, we are having the job tracker as the master node, other nodes are the slave nodes. Like that, we are having various nodes in each rack, right? It might be around like 100 to 200 nodes we will be having in each rack, right? Based on the capacity, right? Based on your requirement and the rack capacity. And suppose if you want to communicate, right? Suppose the data node wants to communicate with the name node, or the data node wants to communicate with another data node. How they will communicate? How they will come? Suppose if you are having two systems, right? If you are having two nodes, if you are having two or more than two nodes, right? So how they are going to communicate within a like I mean to say that within your organization, right? Forget about outside the organization. Within your organization or within your institute or within your lab, you need to connect, right? So you require some switches, right? Switch is enough, right? No need of the router, right? So switch is right? In similar way, in this rack, we will be having a rack switch. So if the name node wants to communicate with any data nodes within the rack, then it will communicate with the rack switch. Then from the rack switch, it will get the information and it will communicate with the corresponding data nodes, right? And similarly, here for the job tracker or the task tracker wants to communicate with the job tracker, then it will use the rack switch, or the job tracker wants to communicate with the task tracker, it will use the rack switch, right? Assume that the name node wants to communicate with the data node which is there in the rack 2. How it will communicate? It has to communicate through rack switch of the rack 1, then it will go to the core switch, then from the core switch it will again go to the rack switch of rack 2, then from the rack switch it will go to the corresponding data node. So the communication will happen like this. Understood? So we should make sure that majority of the communication should happen within the rack, right? So what will happen if the communication is off the rack? Means if the majority of the communication is between rack 1 and rack 2 or another rack, right? What will happen? So assume that our network bandwidth is less, or if it is more also, the data has to be flow, right? So within the rack, the data flow should be, we should make sure the data flow should be less, and outside the rack, the data flow should be, within the rack, we make sure the data flow should be more, and outside the rack, data flow should be less. So this is a Hadoop cluster, the typical Hadoop cluster in the industry, it will look like, right? So then the big companies like Yahoo, Google, they are maintaining this kind of cluster environment, right? So these are the racks, right? So if you see in a row, you might be having around maybe 50 or 60 racks. Each rack might be having a number of nodes, right? So first we'll discuss in brief how exactly the Hadoop cluster architecture will look like, right? Suppose you are the user, right? So if you want, so there is an arrow missing here from the client to name node, okay? So you make sure that what is the first role that here client is not the user. Here client is the SDFS client, okay? So the user will communicate, user cannot communicate with the cluster directly. Okay, so here you make listen that the user, the Hadoop user cannot communicate with the Hadoop cluster directly, right? He has to communicate through client. Okay, here the client first, what the client will do, the client will interact with the name node first, right? Because it is the SDFS, right? Because first you need to store the data, right? If you want to store the data, so where you need to store the data? In the Hadoop distributed file system, right? In the Hadoop distributed file system, what is the master node? Name node is the master node. What are the slave nodes? Data nodes are the slave nodes, right? So the user will submit the data to the client. Client will interact with the master node, that is name node, and then based on the availability of the space of the corresponding data nodes, the name node will distribute the data blocks across these data nodes in the cluster. Okay. Assume that once the data blocks have been distributed, now the user will write the logic, right? The MapReduce program he will write and he will submit to the client, and client will submit the job to the job tracker. What the job tracker will do? The job tracker is the MapReduce engine, right? So in the MapReduce engine, job tracker is the master node and the task trackers are the slave nodes. What the job tracker will do, the job tracker will not submit the job to the task tracker, right? The job tracker has to divide the job into tasks, right? It has to divide the job into tasks, and then the tasks will be distributed across the task trackers. We'll see on what basis the the tasks will be distributed to the task trackers. So, but the general architecture is like this. So we'll discuss one by one what is HDFS. So why we are moving towards the HDFS? Okay, understood. Assume that you are having the data set of 1 terabyte. Okay, and you are having one machine. That machine contains quad core processor. Okay, it has having 4 processor. It is having L1 cache. They are interconnected with the L2 cache, right? And it is having some memory. Okay, and the memory, the main memory is interacting with the secondary memory, and it is having 4 channels, 4 IO channels. For each channel will be 100 megabytes per second. Okay. Assume that this is the configuration. Okay, to load 1 terabyte of data, how much time it is taking for a single system? It is taking approximately 3 hours of data to simply load it. Okay, to simply load it will take 1 hour of time, right? So what will happen when you divide the data into set of blocks, right? You are dividing the data into set of blocks. Assume that you are divided the data set into 100 blocks, okay? And you are having, assume that you are having 100 machines, and you see each machine is having only single processor, right? It is not having dual processor also. It is having single processor, L1, L2 cache, and it is having only 2 IO channels, okay? And but it is having 100 machines. So what it can be done, in on each machine you can have one block of data. Then you can, then what can you can do, you can do the parallel processing here, right? Understood? You can do parallel processing, that is later, but you can load the data, right? When once you divide the data and you load the data in a single machine, like with this configuration, it will not take much time, right? So because the data will be loaded, means it will be done all at the
Hello, sir. So your presentation is disconnected, sir. Hello, sir.
Hello? Sir, Srinivas Naik, sir. Am I audible, sir?
So am I audible now?
Yeah. Very good, sir. We are able to hear, sir.
Can you give the permission to share this?
1 minute, sir. Yes, sir. It's given, sir.
But I cannot. It is not showing here. It is showing you are not the presenter.
And it's showing as organizer now, sir, for me.
Yeah. It is now. It's okay. It might be
Okay, sir.
delayed.
Okay, sir.
So can you see my screen?
Yes, sir. Yes, sir.
Yeah. So when we distribute the data, so it is taking only 3 minutes to load the data, right? So that's why we are going for the SDFS. Okay. So here, when we are going for the SDFS, who is the responsible for managing the data, right? Someone should be responsible, right? And who distributes the data across the cluster? We are not distributing, right? Who is going to distribute the data? And how is data will be accessed? So how you are going to, so once you load the data, how we are going to access the data? So who is doing all those things? So here we need to discuss, as we said, here we are having the master node and the slave node. So we'll discuss about those nodes in detail. So here, master node, as we discussed, we are having the name node as a master node and data nodes as a slave nodes. Okay. What is the role of master node here? What the name node will do? The name node, the data will not be stored at the name node, right? Name node, it only manages the namespace, the metadata, right? It will only manage the metadata. What exactly the metadata contains? The metadata contains wherever the data blocks have been stored, in which of the data nodes these data blocks have been stored. All those information will be there in the name node. So name node only maintains the metadata information. It will not do anything, right? And what the data node will do, the actual data will be stored in the data nodes. We'll discuss secondary name node later. So assume that we are having multiple rack cluster, we are having name node, secondary name node, switches like that. Okay. So as we already discussed these things. Okay. So as I said, the name node is the master node and it will store the metadata of the file system, right? So what is the metadata? Metadata is the information about all the data nodes. Whatever the information that is there in the data node, all the information will be present in the metadata. Wait for a minute. Hello? ఇంట్లో ఉన్నారండి ఇంట్లో వచ్చేయండి కింద గ్రౌండ్ ఫ్లోర్ మయూరి గ్రీన్ ల్యాండ్ కింద గ్రౌండ్ ఫ్లోర్ మీరు ఇంతకుముందు వచ్చారు కదా గ్రౌండ్ ఫ్లోర్ ఇవ్వండి ఒకటే ఉంది గ్రౌండ్ ఫ్లోర్ మొత్తం గ్రౌండ్ ఫ్లోర్ ఇచ్చాను అక్కడ బెల్ కొట్టండి అవును ఓకే సారీ ఫర్ ద డిస్టర్బెన్స్ సో వీఆర్ హ్యావింగ్ ద నేమ్ నోడ్ and data nodes, right? As you know, data node is a slave node, and what exactly this data node will perform? It will perform the read-write operation. That we'll see what kind of read-write operation that we are going to perform. So, how this data node and name node will communicate, right? The communication should happen, right? How these nodes will communicate, right? So, what exactly they will communicate? So, here the name node will never communicate to the data node, first thing. And every time the data node will communicate with the name node. How they will communicate? It will send the heartbeat message. Okay, the data nodes will send the heartbeat message to the name node. What exactly the heartbeat message contains? The first thing is By receiving the heartbeat message, the name node assumes that the data node is alive, means what, it is working. Okay. The second thing is, whatever the data blocks it is having in its possession, all the data blocks information it will give it to the name node. Then name node will verify, because the name node is having the metadata information, right? Metadata, right? Because it will know about data node 1, data node 2, data node 3. In data node 1, what are the data blocks are present. So it will verify, all this information will be verified. Suppose if the data node will not send, or name node will not receive any heartbeat message for a minute or something, 2 minutes, some duration is there, some interval is there. If it is not receiving, then name node assumes that data node has been failed. Okay. Then whatever the data blocks are present, so it will replicate to some other data node that we will discuss later. Okay. So here you need to understand that how these two things will be communicated. At the back end, they are communicating with the remote procedure calls, RPCs. Okay. If you know about RPC, then you may understand. So here they will communicate with the remote procedure calls. If you see here the name node, you have to assume that you are having the file. Okay. You are having the one input data file. Okay. That file first, it needs to be divided into some set of blocks. Okay. Assume that the file is divided into 4 blocks. So what will be the block size? So by default it is 128 MB block, and based on your data set, okay, based on your data set size, assume that your data set size is more, then you can divide each block into 256 MB or 512 MB. It all depends on your data set size. Okay. If it is less, then you can make it 64 MB also. So it all depends on that one. So by default it is 128 MB. You can make changes of the default block size also. Understood? And as you know, we have discussed about the reliability, right? So we have discussed about the reliability is one of the major characteristics of the Hadoop, right? So how the reliability will come? Majorly, what is the meaning of reliability here? If particular data block has been corrupted, or if the particular data block has been lost during the process, then that should be available at some place, some other place. Okay. Or if the particular data node has been failed, it should be available. All the whatever the data blocks which are present in that particular data node, it should be available in some other data node, right? So that's why the reliability matters here, right? So why reliability is important here? Here majorly we achieve the reliability through replication. We are replicating the data blocks into 3. By default it is 3, and based on, suppose assume that your data is very important, okay? Then you make the replication factor as 4. If you assume the data block is only 2, if that is not that much important, you can make it as 2 or 1. That all depends on you. So based on your problem statement, you can choose. But by default it is 3. Okay. So you may ask, right, sir, there are redundancies there, right? So as we said, we are majorly focusing on the data. For us, the data is very important. Assume that we are having the nodes, number of nodes are more for us. Okay. But the data is very important. We should not be like, as an organization or company, I should make sure that I can provide the requirements, the hardware requirements. But for me, the data is very important because it is the customer data. Or I should make sure that the data I should not lose any data. That's why I am having the replication of 3. By default, it is made as 3. That's why the redundancy is maintained. Although we are having this one, right? And as we discussed, name node maintains the metadata, right? Means where actually that particular block of the file has been stored. That information will be maintained. Okay. Assume that we are having 530 MB of file. Okay, 530 MB of file is there, right? So how many blocks we can divide? Suppose if you want to divide 530 MB, and by my default block size is 128 MB, then we can have 5 blocks, right? One is block A to block T, it can have 128 MB. The remaining 18 MB is there, right? Okay. So in other cases, in other platforms, so whatever remaining space will be wasted, right? So the fragmentation will be there. But here in this case, here it is not like that. Whatever remaining space that will be allocated to the last block. Okay, it is 18 MB or 1 MB or 127 MB, whatever it may be, it will be allocated to the block. The space wastage will not be there. Understood? And these blocks will be allocated to the particular data nodes. Okay. So what will happen if that particular data node has been failed? Okay. what will happen? Suppose assume that node 5 has been failed. So tell me what will happen? We will lose the data, right? So we are having our file contains only 5 blocks. Here we are not having any replication, right? Suppose if we don't have the replication, then if our node 5 has been failed, then we will lose the data of block D. Whatever the information that is there in the block D, we will completely lose the data, right? That should not be happen, right? Understood. So we should have the replication. Okay.
Excuse me, sir. I'm sorry to disturb you.
Yes,
Your
sir.
presentation is not visible, sir. We are able to see your video, sir. Presentation is not visible. Please share your presentation.
Yes, yes. I think it might have disconnected. Please inform me as early. Yeah.
Okay, sure, sir. Sure, sir.
Yes. Okay, so here I think you understood, right?
Yeah.
So here we are having 5 blocks, right? You understood. So 5 blocks have been stored, right? And node 5 has been, suppose node 5 data is not there, right? So what will happen? Then we have to go for the replication, right? So here, assume that the replication factor is 3 and block A is replicated thrice. Okay. Like that, we are having all the blocks have been replicated. Assume that now once the replication has been done, assume that node 5 has been failed, okay, or it has been crashed. Then what will happen? So we will lose the data, right? Block B, block D, block D data, we may lose the data, right? But if we lose the data also, the data is already available in some other data nodes, right? The block D is available in node 4 and node 1. Block B is available in some other node 2 and some other node, right? Block is available. So we are maintaining the replication factor as 3. So all the blocks are available. If the node 5 crashes also, we don't have any issue. Understood? So our Hadoop cluster follows the rack-based architecture. Okay. So as we discussed, we have discussed these things, right? So assume that it follows the rack-based architecture, and how in the earlier here we discussed about the replication factor, right? So how we are going to replicate the data blocks, how the system is going. We are not doing all those things. By default, the framework will do, but we should understand how the framework will follow. So it is it is following the replica placement policy as follows, right? One is the data node should contain more than one replica of any block. So I will explain that one, right? So if you see here we are following the rack architecture. In this rack, we are having data node 1 and block A is there. Okay, the block A is placed in data node 1, and here within this data node, I should not have another block. That is the first point. No data node should contain more than one replica of any block. Why? Suppose if I am having block A within the data node 1, my replication factor is 3. I am having the same block A within the data node 1. Then what will happen? Suppose if my data node is failed, then I will lose the 2 replicas, right? So in order to avoid that one, so they are saying that data node should not contain more than one replica. Data node should contain only one replica. What is the second point? Second point is no rack should contain more than 2 replicas of the same block. Okay. Assume that you are having enough racks. Okay. So if you see here, the first point we are satisfied, and the second point is within the rack, right? Within the rack, you should not have more than 2 replicas of the same block. You can have other replicas of other blocks. Okay. So the block A, in the block A is there in data node 6 and data node 8. I cannot have the block another block in the same rack. Why? What is the problem? Because sometimes what will happen is the complete rack may fail. Okay. So the complete rack may fail. If the complete rack fail now, then what will happen? You will lose the data, right? So in order to avoid that one, what they are saying is you should not have more than 2 replicas of the same block in a rack. Okay. What is the first point? The first point is no data node should contain more than one replica of the same block. The second point is no rack should not contain more than 2 replicas of the same block, right? Because if a particular rack failed, then we may get the data from another rack. Understood? Similarly, if you see for the block B, it is there one in rack 2 and another in 2 in rack 3, and block C 1 in rack 3 and 2 in rack 1, like that. So here we are following the replica placement policy in the racks. So as we said, if you see here rack aware, Rack 1 contains data node 1, 2, 3. Rack 2 contains data node 5, 6, 7. Rack 3 contains data node 8, 9, 11, 12. Okay, you see here in this figure. And what is the metadata that name node contains? The result.txt. Result.txt is a file that is divided into 3 blocks, right? Block A, block B, block C. And each block is replicated thrice. Okay, each block is replicated thrice. Block A is there in data node 1, 5, 6. Okay, if you see here 1, 5, 6. Okay, because we are following the replica placement policy. And similarly, block B is there in data node 7 and data node 1, 2. Okay, we are following the replica placement policy. Block C is having data node 5, 8, 9. Okay. So if the complete rack failed, if the rack 3 is failed, also we are having the data blocks. Okay. Understood. So because of this metadata and the rack awareness, if you lose the rack also, we will not lose any data, because for us data is very important. Okay. So this is the master slave. As we discussed, Hadoop is following the master slave architecture. Name node is the master node and the data node are slave nodes. Okay. So what is the network performance that they are saying? Okay. So as we discussed, within the rack, you should keep a lot of communication. Okay. Because if you want to have data transfer, why? Because if you keep the off-rack communication, then the processing will be delayed. Understood. Suppose if the particular data node has been failed in a rack, okay, then you are having we know that as we discussed earlier, it is following the replica placement policy. We know the rack awareness. We can manage because other data blocks are present in some other data nodes in the cluster. Okay, understood. So we are having the reliable storage. Reliability is maintained at the SDFS. Okay. Suppose if the particular rack has been failed, okay, if the particular rack has been failed in the rack, we are having 6 nodes, then also there is no issue, because in the second point, in the replica placement policy, we are having the second point, right? As per the second policy, sorry, second point, we will have some other data block in some other data node in some other rack. Okay, so still we are not losing any data. Understood? So still we will get back the data. So because of rack awareness. So what will happen if the name node is failed? What is the major concern towards the name node? Because the name node maintains the metadata information, right? Name node maintains the metadata information. What is the metadata information? The metadata information contains all the where the particular data blocks have been stored in which of the data nodes. All the information will be stored in the metadata. Where this metadata will be stored? The metadata will not be stored in the secondary memory. The metadata will be stored in the main memory. When you lose the name node or when you restart the name node, you will lose the metadata, right? Once you lose the metadata, can you communicate? You cannot communicate to the cluster, right? You are communicating to the cluster through name node only. If you lose the name node, then it is a single point of failure. Understood? It is a single point of failure. So we'll see how we are going to achieve if the name node has been failed. Okay, we are having secondary name node. We will discuss that one. Okay. So we can have the break for 10 to 15 minutes. Okay, then I can come back.
Okay, sir.
Is that okay?
Sure, sir. Yes, sir. Okay, sir. It's okay, sir. All the participants are requested to take a break and come. We can join after 10-15 minutes. Thank you. That's the ఎక్కడ శ్రీధర్ ఎక్కడ బ్రేక్ పెట్టాలి ఏం సార్ మీ సబ్జెక్ట్ సార్ ప్రణీల్ సార్ మీ సబ్జెక్ట్ అంటున్నా
Sir, shall we start the session?
Yeah, okay, sir. Yes, you can start, sir.
Yes. So till now, what we have discussed is we are discussing about the Hadoop distributed file system. In the Hadoop distributed file system, we know if a data block is corrupted or if you lose the data block, then anyway we are having the replication factor. With that help of that one, we can get the data block. If you lose a particular data node, and the data, if you lose the data blocks also, as per the replica placement policy and as per the reliability structure of the Hadoop, so we can get the data blocks. If you lose the rack also, in that rack we are having some set of nodes, and each node may have some set of blocks also. We can get the data blocks, because as per the replica placement policy, second point, which mentions that a rack should not contain more than 2 replicas. So with that we can get that one. But what happens if we lose the name node? If you lose the name node, what will happen? Because the name node, as we know, name node will store the metadata information, and that metadata information will be stored in the RAM. So if you lose the name node, then what will happen? So we will lose the entire metadata information, right? So if we lose the entire metadata information, then no one can access the cluster. Understood? That is the entry point, the single point of failure. So how we are going to avoid that one? The secondary name node is the earlier case. Means previously we were using the secondary name node. Now we are using some other. Like, we will tell you. We are using the standby name node. Okay? So first we'll understand the existing architecture. So in the secondary name node, we are having the name node and secondary name node. The secondary name node will not exactly the backup of the name node, but whenever the name node failed, then it will take the metadata information. It has to capture the metadata information, and then from that information, the name node can be reconstructed. So that we'll discuss. So as we as we discussed, so name node contains 2 files. Okay, one is FS image, the file system image, and another one is the edit log information. What is the FS image? The FS image is the snapshot of the file system metadata, right? So if you, as you know that metadata is there in the RAM. Okay, the snapshot of the metadata information is present in the FS image. Okay, so once you take the snapshot, okay, once you take the snapshot, then we can have how frequently you can take the snapshot based on your requirement. Okay, like assume that every hour you will take the snapshot. Okay, so at 10 o'clock you are taking the snapshot, and after 10 you are taking the snapshot at 11 o'clock. Okay, so what is the meaning of snapshot? Means suppose if your system is crashed at 10:1, okay, then it will revert back to the previous stage. Okay, but assume that your system has been crashed at 10:20 or 10:30 or 10:40. Okay, so it will revert back to the previous state. Okay, it will revert back to the previous state, but so whatever the information which is like whatever the updation or information, whatever it may be, so it has happened from 10 to 10:20 or 10:30, that information we will lose, right? So in order to avoid that one, so whatever the information that is there after 10 to 10:30, right, that information will be stored in the edit log. So in general, so the snapshot is there from 10 and another snapshot is at 11, means checkpoint time, 12, like that, right? So whatever the information is there from 10 to 11, that will be stored in the edit log information. Okay, I hope you understand. Okay, here the secondary name node also maintains the metadata information that we'll see how it will do. Okay, so assume that we are having three files, file 1, file 2, file 3, and file 1 replication factor is 3, and the block IDs are 1, 2, 3, and file 2, 2, right? Okay, so like that. So here, okay, so it is just only about the replication factor. Here we will not discuss. So as we know that name node contains the FS image and the edit log information. Okay, and the secondary name node will not contain these information. Okay, so what is the secondary name node? Secondary name node will act as a checkpointing name node. Okay, checkpoint means what? So it will continuously fetch the information from the name node. Understood? It will continuously fetch the information from the name node, and it will update in the secondary name node. Understood? So once the name node is down, the secondary name node, it will get the information from the secondary name node. Again, we can reconstruct the name node with the help of the information which is fetched from the name node. So we may not lose the data, but it takes some time, okay? Because it is not the exact backup node. Okay? If it is exactly the backup node, then it will do immediately. In the that is that where we are having the standby name node that we will discuss later. Okay. So as we know, secondary name node will manage or maintain the FS image and edit log information from the name node. Okay. So here, what are the cases that we will consider the secondary name node? Okay, understood. Suppose assume that our name node, you want to restart the name node, right? Due to some maintenance activity or some other thing. So you need to restart, or by default it has been restarted. So what will happen? You will lose the complete metadata information, right, which is there in the FS image. Understood. But that information is present, right? Where that information is present, the edit log information is present in the secondary memory. Understood. So edit log information is present in the secondary memory through edit log. What is the edit log information? The complete information, right? The complete status, the complete status of the metadata information is present in the edit log. Suppose if the system has crashed recently, then it's okay. You can get the information from the edit log, and again you reconstruct the metadata or FS image, right? But assume that the edit log information is for a few days. Okay, assume that how much time it will take to reconstruct the FS image. It takes a lot of time, right? So in order to avoid that one, what they are doing, we are having the secondary name node here. Understood? So this case is before secondary name node. Assume that if you don't have the secondary name node, then this was the case. So it is taking a lot of time to reconstruct the FS image because it has to reconstruct from the beginning. Understood? So here, once we have the secondary name node is not the backup node. Okay, you try to understand. Secondary name node is not the backup node. It is a checkpointing node. Okay. So what this secondary name node will do? Secondary name node will continuously read. What it will read? It will read the edit log information. From where it will read the edit log information? It will read the edit log information from the name node. Understood? Try to understand. So secondary name node will read the edit log information from the name node. Okay. So what is edit log information? Assume that it has been read, the edit log information, it has been read. Okay. So what this edit log, what can we do with this edit log? We will create the FS image, right? We will create the metadata. Understood? Because it will do for every hour. Assume that the checkpointing is there for every hour, then every hour it will update. So in the earlier case, there is no checkpointing, right? So it has to reconstruct everything from the beginning. It takes a lot of time. So it is only 1 hour recreation, so it will not take that much time. So within few minutes, the name node can be active. Understood? So this FS image file we will save to the disk. Then what we will do? We will truncate the existing log file. Understood? Why will truncate the existing log file? Again, what we will do? We will update the FS image file which already. So in the, if you see here, we are having checkpoint 1. Okay, this is checkpoint 2. Okay, in the checkpoint 2, what we are having, we are reading the FS image file, means the previous one, the previous stored one. Okay, then we are reading the edit log file from the name node. Okay, then we are combining these two. When you combine these two, you will get the latest FS image. Understood? You will get the latest FS image. I mean to say that at 10 o'clock and 11 o'clock is the checkpoint H2. Okay, 10 is H1, 11 is H2. Okay, so in between some failure happened, then it has to get the information from the previous one. Okay, previous is the FS image file, and 10 to 10:30 is the edit log file. Okay? It will get the information from that one, and it will merge because this edit log information is stored in the secondary name node. Okay, sorry, in the secondary memory. So we can get the information and we can merge these two, and we will get the latest namespace. Okay, and we will replace it with the existing. We'll replace it with the existing FS image. So this will continue. Okay, this process will continue. So for every hour it will update. Okay. Understood? So for every hour it will update and it will create the FS image. It will not take much time. In the worst case, what it will take, in the worst case, it will have the 1 hour edit log file. Okay, 1 hour edit log file. The previous file will already there. So 1 hour edit log file needs to be merged and to create the new FS image. It will take only that 1 hour time. How much time it will take? Okay. So when you restart this one, it will happen. Okay. So assume that your edit log file size is increasing. Your edit log file size also increase, right? And your name node also fail. Then what will happen? So what is the solution here? You should make some replicas, or you should make some copies of the edit log file, right? So for that we will discuss here how exactly we are going to do that one. So this is in the latest version, they are following the backup node concepts. In the previous version, they were following the checkpointing node concept. So assume that here name node has been failed. Okay, name node has been failed. Okay, so you need to back up two things. Okay, what is the first thing? The first thing you need to back up only one thing. What is the first thing? The first thing is SDFS namespace information, means metadata information. And to back up that one, what you require? You require standby name node. Okay, you require the standby name node. So here standby name node will act as a backup node. Secondary name node will not act as a backup node. Okay? Standby name node will act as a backup node. So what is happening here? We are having the FS image and the edit log file. Okay. So assume that we are having the name node is having the FS image and the edit log files. Okay. That you know, right? So what this concept we will call it as the high availability. Okay. So high availability using the quorum journal manager. So I mean to say that suppose in a cluster you are having 100 nodes. Okay. In that 100 nodes, you should choose minimum 3 nodes. Okay. You choose minimum 3 nodes which will act as a quorum journal manager addition to the other activity that it needs to perform. Okay. These are the slave nodes only, but it acts as a quorum journal manager. Okay. What is the meaning of high availability? What is the meaning of high availability? Suppose you are having the server. Okay. You are having the server which is very critical. Okay, which is very critical, and you are having another standby server. Okay. Whenever this active server is down, this standby server should act as the active server, and the end user should not feel the downtime. Okay, understood? So the end user should not feel that particular downtime. Okay, there will be some downtime, right? So sometimes your website might be hanging, right? But that should not happen, right? So because when you have the high availability, so whenever the server is down, because obvious that wherever in the in Amazon or Facebook or any other companies, their servers will be downtime sometime, right? So sometimes it may face the issue of downtime, but that will not be reflected, right? Because it will have many other active servers, right? It will have the active servers as well as the standby servers. Many standby servers will be there. One is down, immediately it will switch to another. One is down, and it will immediately switch to another. Nearby one, it will switch. That downtime, we will not face that particular downtime. So that we will call it as a high availability. Okay. So how we are going to achieve high availability here, right? So as a client, what exactly you need to do? So you are interacting with the active name node. So so you need to write some program in such a unit means already it has been written. So the framework is like that. Okay. So whatever the edit log information is there, right? That edit log information is written to the journal nodes, okay, which are there in the quorum journal manager. Means so it will be written all the 3. Why? Because if one failed, we can have another 2 like that. Okay. The edit log information is very important, right? So we are replicating to other 3 nodes. We are naming it as journal nodes, and whatever the information that is there in the journal nodes, those metadata information is read by the standby name node. Okay, because it has to creating the metadata. Understood? With the help of edit log, it is creating the metadata, and these are the slave nodes we are having. At the bottom, we are having the slave nodes, and these slave nodes are also sending the block reports, heartbeat messages. So as we said that heartbeat messages contains the metadata information, right? So what kind of data blocks, how many data blocks, all those information will be given to the active name node as well as the standby name node. So it is interacting with the standby name node also. Understood? So how now you tell me how the standby name node will come to know that the active name node is down. So now we are making the copy of the edit log information, right? But we should make, suppose active name node is down, then we should make the standby name node as active, right? So when it will be active, when it will active, suppose okay, so suppose assume that another way I will ask. So if how standby name node knows that active name node is down? It has to know, na? If the standby name node, if it doesn't know that the active name node has been failed or crashed, then the standby name node will not act as the active name node. It has to know, right? For that, what they have done is they have maintained another node with that, in that they are having the zookeeper. Okay? They are having the zookeeper and they are having failover controllers. They are having failover controllers at both active name node as well as the standby name node. Okay, they are having the failover controllers. What this failover controller will do? They will continuously fetch for the zookeeper. Okay, excuse me. So this failover controller continuously fetching for the lock. Okay, so and the standby name node also continuously fetching for the lock. But the zookeeper will give the lock to the active name node because that is active, right? The zookeeper will give the active lock to the active name node, and whenever this standby name node, what the standby name node will do with the help of failover controller, it will continuously what it is doing, it is checking for that whether particular failover controller is failed or not of the active name node. It is continuously getting the information from it. Okay, whenever the active name node has been failed means what? Suppose earlier lock is 1, now lock becomes 0. Whenever the lock becomes 0, this another it will be given chance to the another name node which is continuously in the loop, right? It is continuously in the loop, so it will get the lock. Now the standby name node will get the lock, then the standby name node will become the active name node. Understood? So do you have any queries till now? Meeting. Task. So do you have any queries? Let me know. Okay. So as I said, whether I'm going fast or whether I'm going slowly or whether I'm teaching you properly or whether you already know these concepts or something, if you explain, then based on that one I can fasten or I can slow or I can take another topic or like that. It should be interactive, otherwise one-way discussion is not good. So okay, as we discussed earlier, so the data nodes will perform, the name node and data nodes will communicate or perform the read and write mechanism. So first we'll discuss about write mechanism. So what is write mechanism? What is the meaning of write mechanism? A write mechanism is you are loading the data. Write means what? You are loading the data to the cluster. Understood? That is write mechanism here. So what so you cannot, as a user, first you should interact with the HDFS client, and through HDFS client only you can interact with the name node. Okay, here we are having name node and set of data nodes. Assume that you want to create a file. Okay, so that file is already there. So if you want to create a file, then the name node will check whether the existing file with the same name is there or not. Okay, if it is there, then it will reject and it will ask you to change the name of the file. Then if it is means if it is that file is not there, okay, then it will give the success message and it will inform you that the space is available. So it will get many information. One is it will check the file name whether it is existing or not, and it will check whether the enough space is available or not in the cluster. So if everything is there, then it will give you the acknowledgement. Based on that one, what the Hadoop client will do, he has to pass the data, right? He has to write the data. So how it will be written? So for that, you will have the one class called FS file system data output stream class is there. With the help of that class, the data has been written in that class. Okay. So that is 128 MB block of data. Okay. So then this block allocation will be requested to the name node. Okay. Because what exactly the name node contains? The name node contains the metadata information. In the metadata information, we will know that which of the data nodes are free, right? Which of the data nodes are free, and we also need to follow the replica placement policy also, right? And also it has to follow the rack awareness also. So it has to make sure all those things will be attained. Then it will allocate the request. Okay. So then, based on the availability, it will say that data node 3 is allocated, right? Then the SDFS client will directly write the information of 128 MB to the particular data node 3. Understood? So once it has been written, then another block will be created, right? So because the file.txt might be having 2 blocks or 3 blocks or 4 blocks, right? So based on that one after the other, the blocks will be created. Okay, then you will return the acknowledgement, and for the another block, we are making the request, and for the data node 1 is allocated. So the 2 blocks, assume that the file is having only 2 blocks, the 2 blocks have been allocated to the particular data node 1 and data node 3. Okay. But what we need to make sure that whether the replication factor is achieved or not. So we should make sure that the replication factor needs to be achieved. So this is the first step. What is another step? So we cannot write continuously, right? So you should, in order to make the replication factor, here we are following the pipelining mechanism. Understood? In the pipelining mechanism, assume that we are having the file that is divided into 3 blocks. Okay. In these 3 blocks, first the data block, assume that data block A has been written, then data block A will be written to data node 1, and because based on the availability, and then again data block A is written to data node 7 and data node 9. If you see here, we are following the replica placement policy if the replication factor is 3. Understood? So data node A is written here, it is written here. Okay. Similarly, it will happen for another data blocks. Okay, data block B and data block C. Okay. Then the client, it should be updated in the rack, in the name node metadata information, as well as it should be given information to the client that it has been written. Okay. So the acknowledgement will be sent back. Okay. Acknowledgement will be sent back, and it will be updated in the metadata that particular blocks have been received, and it will be informed to the client also. Understood? So this is about the write mechanism in a broader way. And the read mechanism. What is the read mechanism here? In the read mechanism, just the data is already been written to the cluster. Okay, means we are having the data blocks. Suppose you want to read the particular data block. Okay, how you are going to read the data block? Okay, so data is already there. You want to read. So for that, you need to write some with the help of open system calls. It will approach the name node to get the block locations, right? So it will say that the particular file data block 1, it needs to be read. So the name node will give the metadata information where the particular data block has been stored, and it will give the correct location, and with the help of file system data input stream clause, it will read the data whichever it is there, wherever it is there. So file system data input stream will fetch the data, means for reading purpose, it will fetch the data from nearby location. Okay, nearby location to the particular cluster, and it will fetch the data, and it will get the information to the client for reading. So with the example, so that you will understand better. So if you see here, everything SDFS client will be there in the client JVM, in the client node, and assume that it needs to read data block A and data block B, and it will send a request to read block A and block B of particular file to name node, because name node already knows that the particular file data blocks where it has been stored with the help of metadata, and this name node will send the locations or the particular IP address of the blocks where of the data nodes where these blocks have been stored, and then these clients interact with the corresponding data node through rack switches, core switches, and then it will get the information. Understood? So once it has been read, okay, once it has been read, because we know that the replication factor is 3, the 3 places this information is there. So we will fetch the nearest place, and once the data has been read, then it will give the information to the client that data has been read by the client. So what we discussed till now is we have discussed about how we have stored the data. Okay, how we have stored the data. Now assume that we know how to store the data. Okay, now we need to process the data. So whichever the data that we have stored, we need to process that one. So how we are going to process the data, right? So as I said earlier, so they have written two white papers for the Google file system, right, and for the MapReduce. So these two white papers has been written by Jeffrey Dean and Sanjay Gemawat by Google in 2004. Given the process, they have not given the implementation details how they have done exactly, but they have given they have given the outline how the process has been worked. So with the help of this one, so the dog cutting is the Hadoop founder. So he has implemented the white papers which are written by the Google scientist, and he has implemented those things and he has named it as the Hadoop. So if you see the workflow, the general workflow, so here you are the user. So what you will do, you will write the logic, right? So here you are having the cluster, okay? So before writing the logic, so first you need to know where the logic needs to be performed, right? So first of all, for that you need to load the data into the Hadoop distributed file system. Once the data is loaded, so you have to write the MapReduce logic. Then you are submitting the MapReduce job to the cluster. So these aspects are in a broader way, right? We'll discuss in detail. Okay. Then once you write the submit the MapReduce job, you will get the results. Okay. Then those results will be output will be given back to the user. Okay. Suppose this is assume that this is you are having a typical Hadoop cluster. Okay. But assume that you don't want to work in a typical Hadoop cluster and you want to work in a on the cloud. Okay. If you want to work on a cloud, because assume that your requirement is only for a year or 6 months, right? For that, it is not good to bring it is not to buy the hardware for that, right? Because after that you may not require the particular nodes to, and it will be waste of money, right? So the cost cutting they will do, and they will go for the cloud environment where the platform or the infrastructure will be, they will get the infrastructure whatever that you require with the help of. So there are many cloud platforms are available. For assume that for example we are having the elastic cloud compute. So from the elastic cloud compute, it will allocate the Hadoop cluster based on your requirement and the costing. Okay. Once it has been done, then the process is similar, right? So you send the data to the cluster and you move the data into the HDFS. You write the logic, you submit the MapReduce job, okay, and you move the data, okay, from the cluster, right? You have to move the data, right? Understood. So then what will happen, right? So where this data has been gone, you cannot load because this is the computing cluster, right? So in Amazon there are for the computing you will have requirement, and for the storage you will have the requirement. For computing you can go for the EC2 cluster. For storing the data you can go for the S3, like simple storage service, right? So where this data has been gone, right? So so initially the data has been stored in the S3, right? Simple storage service. This is also cloud platform. We can store the data here. Whenever we require, we copy the data from S3 to HDFS where it has been there in the EC2 cluster. Okay. Then once you will get the results, right? So those results will be stored back to the S3, and the data whichever is there in the EC2, that will be cleared, right? So because on the cost requirement or how frequent you are using the data, it all depends, right? So there's many factors will depend where exactly you need to store, how frequently you need to switch, like that. Okay. So as we discussed, the user, what you will do, you will write the MapReduce job and you will submit to the job tracker. So in the MapReduce framework, the job tracker is the master node and the task trackers are the slave nodes, right? So as a user, you will submit the job to the job tracker, the MapReduce job, and this MapReduce job, we are having the mapper function and the reducer function. This job will be divided into tasks. Okay, this job will be divided into set of tasks. So these tasks will be scheduled to the task trackers. Okay, how this task will be scheduled to task trackers? Suppose assume that the particular node, assume that the node 1 is having quad core processor. Okay, quad core processor, and assume that node 2 is having octa core processor, and assume that node 1 quad core is full, right? And in the octa core, on the 6 cores are full and 2 cores are available. Okay? 6 cores are busy and 2 cores are available. So the job tracker can give 2 tasks to the corresponding task tracker. Okay? Understood? So it will, the task will be given to the particular core, right? Available based on the availability of number of slots. Then availability of number of slots will depend on the availability of the number of cores, right? Like that, slot distribution will be done in the job tracker. So this is the brief one: submit job, schedule job, right? So then, so this map task requires the data, right? So within that particular data node, the data is present. From that, it will fetch the data. Means in that data node itself, the data is available. Okay, that slave node itself, and it will whatever the output that the mapper will generate, that will be there in the local file system, not in the distributed file system, right? So then it will get back to the reducer, and you will get the final. So these things we already discussed about the data distribution. Okay, I will skip this one. Okay, so you listen. So this one. Okay. So here, if you see, we are having the blocks, right? We are having the blocks. Suppose assume that you are having 4 blocks. Okay. So for each block, the one mapper function will be like, you will not write this many number of mapper functions, right? So you will write only one mapper function, right? So this mapper function will be for each block. This mapper function will be allocated, because you need to do the parallel processing, right? Understood? Suppose your one system is having the quad core processor, and if all four cores are available, then these 4 blocks can run in that one, and you can do the parallel processing, right? Understood? So whatever the output that will generate, so the mappers will generate the intermediate output. So all these intermediate outputs will be given to the reducers. Okay. So why IO0, intermediate output 0 and intermediate output 2 will be reduced together, and intermediate output 1 and 3 are reduced together? Because they are having the same key here. So here everything will work in terms of key value pairs. Okay. Whichever is having the same key, so those will be reduced together. Okay. So in between, this process is called shuffling process before it is given to the reducer. Okay. So we are shuffling the data, and we are getting the final outcome. Okay. So here we are having map phase and the reducer phase. These are the 2 phases that we will be having the map reduce. So in the mapper phase, we will just, mapper function will run for each block, and it will generate the intermediate output. In the reducer phase, the shuffling will be done based on the same key, and it will be given to the reducer to get the final outcome. So as I said, everything is in terms of key value pairs. The input split, whatever you are having, that is also should be written in the key value pair. And because the mapper function will only understand the key value pair, it will not understand anything else. Whatever it is, whatever the data that it is there, it needs to be converted into key value pairs. Okay, it is done with the help of input splits. Okay, so that we'll discuss, and it will be given to the mapper function. The mapper function, it will generate the intermediate output. Intermediate output is also in terms of key value pairs. Okay, and it will be given to the reducer function, and reducer function will also generate the key value pairs as output. So here I mean to say that everything is in terms of key value pairs. So what is the meaning of partitions here? So here, if you see here, assume that we are having 3 different colors. Okay, so these 3 different, so assume that these are based on the same key. Okay, these partitions are based on the same key. It will be given to the one reducer. Same key, whatever it is there, it will be given to the one reducer as an input. Okay, so that's why these partitions have been done. The partitions means whichever having the same key. So you may have 3 or 4 or 1 partition or 2 partition. It all depends on the distinct keys that you are having. So network topology, that it will follow the tree style network topology that we have discussed earlier, because many of the data centers will follow the same thing. And as we discussed, nodes, the nodes that which are in the same rack will have higher bandwidth as compared to the off rack. That's why we are saying that majority of the communication should happen within the rack, because it will have the higher bandwidth. You are having 2 nodes, okay, but assume that in the cluster you will have more than 2 nodes, but at time being you assume that you are having 2 nodes in this cluster, okay. You are having the file, okay. So it is it is a local file system, okay. You are having the file in the local file system or any other third party or any other device, secondary device. So you are loading the file from local to the SDFS, okay. Understood. So what this input format will do? Input format will divide your data into blocks. Understood. So as we discussed, based on the input format type, right? You might be having different input format types. So we cannot divide as it is, right? So we have to divide based on your input format type. Okay. So it will divide based on your input format type, and it will divide into 128 MB blocks. If it is by default is 128 MB blocks, and based on your requirement, you can change the block size. Okay. So assume that it has been divided into 3 blocks. So whatever the block it is having information, the block information. So it is a text file, right? Or assume that it is a text file. Okay. And this mapper function will not understand. So for each block or each split, one mapper function will be given, right? And the mapper function will not understand whatever it is written in that particular block. So someone needs to convert that block into key value pairs. As we discussed in the earlier slide, that mapper function will only understand the key value pairs, and for that input is the key value pairs. Okay. So for that, what this record reader will do, the record reader, so record means you understand. So one record, this is one record. So it will read record by record. It will read, because in a particular block you might be having hundreds of records. Okay? It will read each record one by one, and it will convert that particular record into key value pair. Then come to the next one, like the next one, till end of the line. It will end of that particular one. It will complete converting into the key value pair. Okay. Then this will be given as input to the mapper function. Understood. So these key value pairs will be given as input to the mapper function. Then what this mapper function will generate, because you might be written some logic, right? Based on the some problem statement, you might have written some logic. Based on the logic, it will generate key value pairs. You write any logic, it has to generate some intermediate key value pairs, right? So once it has generated intermediate key value pairs, so the whatever the key, like suppose here we are having only 2 nodes, right? Suppose you are having 100 nodes. Okay. In the 100 nodes, the keys might be, it will check for the same key. Whichever is having the same key, those keys will be shuffled together. Okay. Those keys will be shuffled together. Understood. And it will be like within the after shuffling, suppose they need to be sorted. Okay, then the sorting operation will be performed. Then it will be given to the reducer to get the final output. Okay, and these final key value pairs will be again converted into will be kept in the output format, and again it will be stored in the SDFS. Okay, understood. So this is the workflow of the Hadoop MapReduce. Okay. So assume that this is the mapper function. Suppose assume that you are having the word count program. So here you are having the mapper function. Okay. So this is the logic of the mapper function. Okay. You need to count the number of words. Okay. And here it is the reducer function. Okay. So here you see the data types are and everything is different. Okay. Int writable, long writable. It is a completely different chapter. So just for you need to understand that there is a mapper function, the logic that you need to write, and the reducer logic that you need to write. So there might be some number of input files, various input files might be there, and the input format based on the input format. Suppose if if your input format is text input format, okay, then what is the key? Key is the byte offset of that particular line and the complete line, okay. The byte offset and the complete line is the value. Key is the byte offset. The initial it is 0 is the key and complete text is the complete line is the text line is the value, right? And for the next one, the byte offset will be the counting, right? The counting, and after the new line, the next byte offset will be there. The next new line will be there. That is the next byte offset and next line. So like that for the text input format. And for the key value input format, suppose you are having some assume that you are having the name, right? You are having the name and you are having the salary or organization where you are working. The first line, the first name is the right, name is the right. That is the key. The remaining everything will be the value, right? In the key value input format. And for the sequence file input format, the key value pairs you can define, right? You can define based on your requirement. So input splits we have already discussed based on your requirement. The default is 128 MB. You can divide it into input splits. Okay. Yeah. Any queries you are having or? Record reader. So what will do? Someone is speaking out, so better you turn your mic.
Madam,
Sir, now you please unmute, sir, yourself. I muted all people. Yes, sir.
So as we discussed earlier, the record reader will convert. It will go to the particular block line by line, record by record, and it will convert into key value pairs, and it will give it as input to the mapper function. Okay. So these things we already discussed. Okay. So it is like how the key value pairs will be partitioned and it will be given to the reducer, right? So with the same key. So how the system knows that it has the same key, right? So it will perform the hashing on each and every key, whichever values are same that are into one partition. Okay. So as we are having the input format, we will be having the output format. Okay. Then it will be loaded into the database. In the SDFS. So the combiner function. So these combiner functions can be used. Suppose instead of assume that instead of reducing everything at the reducer function or sorting out everything at the shuffling process. So in order to avoid some of the things, you can also use combiner function. Suppose here if you see they have given the year and the temperature. Suppose the problem statement is to find the maximum temperature in a year. Okay, so you can reduce some of the output here itself, right? 1950 and 20 is the maximum temperature. So you can do some of the things at the mapper function itself because everything needs to be shuffled, right, in the cluster. So it will consume a lot of bandwidth and it may take a lot of time. In order to avoid that one, so combiner function can be placed with the mapper itself. So these things we all discussed. So I will briefly explain the client. What is the role of client is to submit the job and to get some information. What is the role of job tracker is to accept the map reduced job and assign the mapper or reduced task to the workers, or we can say here the task trackers, and to monitor the task. If any failures are there, so it has to do that one. So it has to monitor the task, and the task tracker is where actually the main task will be run, mapper reduced task. Okay. So as a user, first what you will do, you will input the files to the Hadoop distributed file system. Okay. Then once assume that the data is there, then you will submit the job, and then the third point is you will get the file information, right? Because if the whatever the block is there, right? For the suppose assume that the file one we are having block two, right? But in that some slots are not available. You are having some other task, right? So you cannot run that particular task, right? So to make sure that we should make sure that there is a data locality is achieved here. Otherwise, we need to wait for that particular point of time to achieve the data locality. Okay. Then we submit the job to the job tracker. Then what the job tracker will do, read the job files and it will get the information from the SDFS. Okay. And after that, this job tracker and task trackers will communicate with each other, as we said, through heartbeat messages. And in that heartbeat message, only the job tracker will piggyback the tasks, right? It will not send any message to the task tracker. It will perform the piggybacking. For the particular heartbeat, it will get it will, whenever the heartbeat is received by the job tracker, it will assign the task to the return journey, right? Because once the heartbeat is received, it will do the acknowledgement, right? So through acknowledgement, the task assignment will be done. Okay, so these are just based on the availability of the slots, right? So because based on if you don't have slots, then you cannot assign the task. So here we will be having various scheduling algorithms like excuse me. Suppose you are having multiple jobs, right? Whenever you are having multiple jobs, how the scheduling will be done. So in the earlier, we used to have the only first in first out scheduler. After that, we are having many other schedulers. One of the scheduler is the fair scheduler, because when you are having a multi-user environment, every user needs to get the cluster, right? So we cannot unfair the situation. So every user must get the fair based on his requirement. So as we know, master slave architecture, so job tracker will not interact with the task tracker. Task tracker just request the job tracker to get the task. Then the task tracker will give the task to the corresponding task tracker. Okay. It will happen in this way. So that's why we will call it as a pull scheduling strategy, not the push one. Push one means what? The job tracker will push the task to the task tracker. So it is just the pull scheduling strategy. Okay. So here, as we discussed here, map task scheduling and the reduced task scheduling. So we are if the particular task has been failed, so that we will discuss in the next slide. So here first we'll discuss about the data locality concept, because it is one of the important research aspect, because still we are facing the issue in this environment. Assume that we are having a set of task trackers, okay, and we are having file one is divided into two blocks, 1, 3, file 2 is 2, 4, 5. Okay. So if you see here, the task tracker, the first one, right, the task tracker is having the corresponding data block. So here the data is local. Okay. If you see in the second node, the task tracker is assigned because the slots are available. But 1, 2, 3, 4, 5, 6, 7. If you see in the seventh one where data node 3 is there, their slots are not available. Okay. In the 5 and 7, the data slots, means number of ports are not available. The system is busy there. So that's why it is not assigned there. So data is not local here, right? So then the data needs to be transferred. So it will cause the data. So we should work on this aspect. So I will briefly explain what are the different types of data locality is there. So whenever the mapper function is there, if the data block is available within that particular data node, then it is we can call it as data locality is achieved. Okay. Suppose the data block is there in one data node and the slot availability is there in some other data node within the same rack. Okay, within the same rack. Then we will call it as a rack local map task. Okay, within the rack we are achieving the local data locality. But sometimes what will happen is data block is there in some other rack and the slot availability is there in some other rack. Okay, it is called off rack, right? Off rack map task. So 99% we try to avoid this off-rack map task. Within the rack, sometimes it might be possible based on the how busy the cluster is, but we should avoid the off-rack map task. Okay. So earlier we have seen what happens if the particular data node crashes or data block crashes or the particular complete rack crashes, right? So similarly for the fault tolerance is also achieved in the map reduce. If what will happen if a particular task has been crashed? The task can be the map task or the reducer task, right? What will happen? So when it is a map task or reducer task, what can we do? What can we do? Whenever it is a map task, we can restart the particular task, okay? Because there is no dependency available for the map task because that is the first stage, right? But whenever the reduce task has been failed, reduce task has been failed means what? Where we can get the input to the reducer task, we'll get from the particular disk, right? Because the mapper is written, the mapper will return the intermediate output in the disk, right? So from the disk, it has to get the data, right? So again, the particular reduce task can be restarted. So what will happen if the particular node has been crashed, right? If the node is crashed, then what can we do? We can again relaunch the particular task on some other node where the particular data block is available. Understood? And what will happen if the particular task is running slowly? Okay. Whenever the task is slow, what will happen when the task is slow? You cannot, if you don't identify the particular task which is slow, then your system may lead to means it will be delayed, right? The results will be delayed. So the straggler task needs to be identified at the earlier stage. So how to locate the straggler task? Okay. Assume that your progress score, your task. So here we have taken progress score of task 1 and task 2. If the progress score is if the average progress, if the progress score of a particular task is less than the average progress score of all the tasks, then we can easily say that the particular task has been slow, right? Then we can relaunch the particular task. Okay. Whichever is slow, then we call the task as a straggler task. Understood. So now we have identified the straggler task, right? The slow task. These all are the research concepts. So I am not explaining through papers or results because once you understand the basic fundamentals, then it will be easy for you to understand those concepts. So what is a speculative execution? So whenever we say that particular task is slow, we have identified the particular task is slow, right? So then another data block is available, right? We will be having, because replication factor is there, right? We will be having another data block. There we will run another task. Okay, whichever task is running faster, whichever task executes first, we'll consider that one remaining will be discontinued. Okay. That is called speculative execution. So till now we have discussed about the MapReduce version 1, right? Now we'll discuss about the MapReduce version 2 or 3. So in this MapReduce version 2 or 3, we will call it as a yarn. It is yet another resource negotiator that we have discussed, right? In the MapReduce, what is the problem? In the MapReduce, you can only do work for the batch processing, right? But in the yarn will act as a resource manager, where on top of it, as we discussed in the earlier Hadoop ecosystem we have discussed, right? On top of yarn, you will having the batch processing like MapReduce. You will be having the in-memory processing like Spark. You can run the Hive, HBase. You can coordinate the jobs. Like you can have many other tools, right? Which you can run on top of the yarn, right? So as we discussed, it is a okay. So this is the earlier one. So now we are having the yarn. So after that, assume that assume that we are having a different storage system or framework for each of these systems. Okay. For batch processing, we are having different storage layer and resource manager, and for the Apache Spark, we are having different storage layer and resource manager, and similarly for other tools, right? But sometimes what will happen? Some of the programs are whenever you are having a project, you may not work on single component, right? So sometimes you may have different modules. One of the module might be running on the MapReduce, another module might be running on the Apache Spark, another module might be running on the for the stream processing, right? So you might be having various modules. So for if you want to coordinate, it will be very difficult, right? So because we are having different resource manager and storage layers for those things. So in order to avoid those things, we are having the yarn. So yarn will act as a resource manager. It will provide the resources for all these platforms. Okay, and HDFS is the same for storing the data is same for all the other frameworks, right? Because it will be easy to switch between these two frameworks whenever you require your coding. So as we discussed the ecosystem, so now you may understand properly why we are going for the yarn as a resource manager. Okay. So yarn will have some of the components. So I will explain those things within 5 to 10 minutes, and I will close the session here. So what are the advantages for the yarn? Why we are going for the yarn? As we discussed earlier, is a single cluster approach, right? Now we are having many other clusters, right? So the cluster utilization will increase, understood? Because we are having at the base the HDFS is same, right? And the cluster resource will be utilized, and lower operational cost, right? Because we are having, as I said, we are having only one cluster to work on all the needs, right? And reduce the data motion, right? So if you don't have the one single cluster, then you may need to move the data from one cluster to another cluster. Here, no need to move the data, right? So you are working on the same cluster. So this is the MapReduce version 1, where we are having the master node as a job tracker and name node, and the slave node as a task tracker and data node. Similarly, in the yarn MapReduce version 2, 2 or 3, so whatever the latest might be. So what is the master here? The SDFS is remaining same, right? SDFS is same. The name node and the data nodes are same. But when it comes to the MapReduce, right? Here we are having the resource manager as the master node and the node manager as the slave nodes. Okay, understood. And the node manager contains the application master and container. So we'll explain one by one. So what are the major components of the yarn? One is the resource manager. We will have one resource manager per cluster. Means what? One master node, right? And one node manager per data node. For each slave node, we will have the one node manager. It will take care of the particular node. Okay. So one name node, one resource manager will be having. So what is the role of resource manager here? Resource manager is a master node, right? Understood. So it will mainly work for it will mainly schedule the jobs, okay, and it will mainly manage all the applications. Okay. What the scheduler will do here? What the scheduler will do? It will check what kind of scheduler is required based on the jobs that you are having, right? Whether first node or phase scheduler or capacity scheduler or any other scheduler that you are developing, right? And it will keep track of all the tasks that you are having, that it is having. What this application manager will do? So it will take care of the applications, whatever the applications means job, whatever the jobs that you are submitting, right? It will make sure that the particular container is available. It should allocate the container. Container means what? Here the resources, right? The resources needs to be allocated to the particular application, right? So that is taken care by the application manager. So, and what is the role of node manager here? The node manager will completely look after the node, right? So whatever the resources which are available, like container, and it will also manage the applications. So application master will manage all the applications. So the application master will be related to particular application. Application manager is related to all the applications in the cluster. Okay. So here, application master mainly works on the life cycle of the particular application. So the whatever will happen for the application master, it will take care of the whatever the execution flow or faults, whatever it may be, it is taken care by the application master. Okay. And when it comes to the container, container, what container exactly contains? The container contains the resources. Means for particular application, how many resources are available, what percentage of CPU is available, what percentage of memory is available, what percentage of disk IO, network bandwidth. So everything will be there with the containers, right? So these are the container groups, right? Suppose if you are having the octa-core processor and we are having the 4 memory slots, then the container group 1 may require 3 cores and 12 GB RAM, and the container group may require 2 cores and 8 GB RAM. Based on the requirement, the container group will allocate. So, so if you see here, as a client, I will submit the job to the resource manager. Then what resource manager will do? Resource manager will request the node manager. Okay. Resource manager will, because a resource manager will not have the containers, right? Resource manager will request the node manager to have the container. Okay. Then what the node manager will do? The node manager anyway is having the containers, right? So the node manager will launch the container. So whatever the application is there, the application master, the complete life cycle of the application is there, the application master, right? That will be running the container. Okay. Then this application master requires the containers to run the particular task, right? Understood. For running the application master also you require the container. Understood. And for running the particular application you require containers. So it will request the containers to the resource manager, and resource manager will provide. Resource manager again requests the node managers to provide the containers. Node manager will provide the containers, and this application master will launch the task in those containers, and it will run the particular task. Okay. So if I explain through this mode, then you will understand more better. So I will quickly explain. Assume that I'm having two blocks of data in data node 1 and 2. Okay. And I'm submitting the job to the application master. Okay. So what the application master is do? It will, for the application master also you require the container that is already launched. Okay. And application master will request the name node where the data is available. Okay. So it will mention in node 1 and node 2 data is available. Then what this application master will do? Application master will request the resource manager that I require 1 GB RAM and 1 core to run the particular applications in those nodes, data node 1 and data node 2. Then what this resource manager will do? Resource manager will request the node manager to provide the containers, whatever the requested by the application master. Then what this node manager will do? What this node manager will run the task inside the containers with the help of application master. Understood? Application master will run the task in the containers. Once it is done, then it will give information to the resource manager that everything has been done, okay, completed. So I think I don't know whether I am fast or slow. So if you have any queries, I have completed. If you have any queries, let me know. So for 5 to 10 minutes, we can spend on queries. Any research queries or any other queries if you are having, let me know. Because these all are theory sessions, so I don't know how much you understood. But if you have practical, then you will understand better. So if you already know the concepts, then you may understood it is better. And if you are towards research in this domain, you can contact me. We can have discussions. I can help you in that one. So do you have any queries?
Sir, this is Ashfa. Sir, what is the open platform we can use for implementing all these big data related things?
If you see, we are having the Apache core. Okay, that is open source. It is available. Okay, you can set up the multi-node Hadoop cluster there with the help of the core functionalities. Everything is open source. Okay.
Okay, sir.
So you can experiment on that. You can take at the beginning. You can take two nodes. You can make one node as a master node, another node as a slave node. Once you are done with that multi-node Hadoop cluster, so in many resources are available in the internet where you can set up the cluster. Okay. And if you really want to set up the cluster, if multi-node cluster, if you are having any issues, then you can contact me. Then I will provide the feedback or I will give you the suggestions.
Okay, sir. Thank you, sir.
So anyone interested in doing research in this domain, also you can contact me. Not only in this domain or any other domain related to this topic, because these are my PhD related work. After that, I'm doing this work as well as I'm into AI in agriculture or health sector, because those are mostly towards the application based. I'm doing both the research, right? One is application based research, another one is the core research. So to get the projects, we need to, in the core research, it is difficult to get the project. So because where we are developing the core libraries and we are developing the scheduling algorithms. So for if you want to get funded projects, then you need to go for the application based research where it will be used for the end users. If you want to do PhD, then you have to work in the core. because in application based you may not get good papers. Means publication is difficult in good journals, in Q1 journals. Any queries? Please, you are welcome. So if you are nearby colleges, we can have interaction. So if you are done MTech, and because we have seen that many of the faculty are coming directly towards the part-time PhD, but before coming for that one, if you are anyone interested, you have interaction with the faculty, whoever you are interested. You discuss with them the problem statements. If you have interaction for at least 6 months, then it will be easy for the faculty to select the like as part-time if you are interested.
Yeah, sir, definitely, sir. I think if no one is having queries, we can close the session, sir. And sir, Dr. N. Srinivasan, sir, it was very useful session, sir, and also it was so much informative. And we are very much thankful from our organization, sir, for you. And in spite of your busy schedule, and thanks for participating in this session, sir. It was very much useful as well as informative, sir. Thank you so much, sir.
Thank you, sir. Thank you for the opportunity. In the coming days, also, if anything required, I will be more happy to communicate in physical mode. So, because where we can have the lab sessions as well.
Definitely,
Thank you,
sir.
sir. Thank you once again.
Yeah, thanks, sir.
Shall I leave, sir?
Yes, sir. Yes, sir. Thanks a lot, sir.
Okay, thank you.
Yeah. And dear participants, now there will be a lunch break, and we will resume the afternoon from 2 p.m. So everyone can have a lunch, and we will again resume the session at 2 p.m. today. Thanks for participating, everyone.